So the final stage of modifying the main board is soldering the 6 connectors, 27 wires in total, to the tap points on the main board. You can see this is a prototype. This is version 1.0 prototype. Try to remember when you're soldering these that you want to be able to pull them in and out without putting undue stress on the tap points. You know, that's why the wires are a little bit longer than needed. None of them are really tight that it's going to be, you know, every time I plug in or pull it out, it's going to kind of be pulling on that solder joint. And you'll notice these are tack points. They're not actually to pads or to vias. Those I've actually got curved. You can see it over here with these power lines too. I've got them curved way up and coming back down again. So again, when I plug and unplug these, the movement of the unit is going into the curve of the wire and not into the tap points so much. So that's just a general thing to keep in mind. If you buy the boards, you'll be getting these connectors that are already pre-made with the general lengths you need, actually longer than what you really need, so there's plenty of excess wire, and they will be already connected and stripped, so ready to go. You might have to trim down the stripped ends a little bit once you solder them, before or after you solder them into place, but basically they're ready to go. And all of them, let's see, 6, 12, 18, 21, so 21 of the 27 wires are using Kynar, this 30 gauge Kynar coated wire. This is typical wire that's used for wire wrapping, which is easy to work with. It's silver plated, very easy to solder. It's very small, so it goes through the tiny vias on the board at the points where you can go through vias. And since they're not, you know, none of them are carrying much current, they're totally fine. And then 6 of the wires are thicker, 26 gauge. These are the power connectors. You got 5-volt ground and bias to the interconnect board, and you got 5-volt ground and the LED strobe line to the output board on top. So we're going to do these first. Best thing to do is these 2 are for the top board and the rest are for the interconnect board. We're going to do these 2 top board ones first, because if I did the interconnect board first and then this afterwards, I would be trying to solder at places that are around these wires, and then, you know, I might hit one of these wires with a soldering iron. So do the top board first, the output board first, and then the interconnect board later, because you won't have that problem in reverse. Of the 6 connectors, I'm starting with the one on the top right of the output board, the top board. This one right here. These are the 3 wires for the rhythm triggers out. Now the vias they connect to are underneath the top board, so I have to remove that to get at them. Now you'll notice when you're doing these, keep in mind the direction that these connectors are polarized. Keep in mind the direction it has to plug in, and the way that the wires have to bend to make it come in and out in order to, you know, plug in and remove this board. So, and also it's worth noting on the bottom of these boards, by the connectors, there's labels that indicate where on the schematic of the main board they have to be tapped to. So as long as you have a schematic of the main board and you read these, you can double check. With this connector, the 3 wires go to these 3 vias. So what I'll want to do is bend these wires around so that they're going to the vias, and this thing is sitting in the approximate place it has to be to plug in and out, plug in and out of the connector. So I'm going to kind of bend these wires back around this way to get them where they sort of have to go. And then once I get them bent in the approximate place, I will stick the wires through the vias. There's one of them right there. Example, stick it down through the via and then bend it flat to the board and around like that. So you can see the general way those are going to go. So here's what the connector looks like soldered in place. I've got it bent down and laying close to the surface of the board. That means when I attach the top, the plug is basically in the correct position. So it makes it easy to plug it and unplug it from that position. Because I've bent the wires and curved them back, none of the strain is on the joints themselves, but it's mainly in the curved part of the wire. So here are the vias I soldered on the bottom of the board, the 3 trigger outputs, with the extra wire already clipped off. One thing worth mentioning, some of the vias might have some solder mask on the pad, which makes it difficult for the solder to adhere. And there are 2 things you can do to deal with this. One is to take a small round file like this. Then after you've drilled out the via, but before inserting wire, put the tip of the file on the via hole and just work it around to scrape off some of the solder mask. Another thing you can do, as I did with these vias, is to make sure to keep the tinned tip of the soldering iron on the pad long enough to heat up the copper inside the via. So that some solder travels up into the plated through part. You can usually see when that happens by some of the solder disappearing into the hole. I'm going to do the second connector on top now, the one that is on my left. Now these are all power connections, so they're thicker wire. I'm using 26 gauge here. And these are all going through vias on the board as well. And I'm going to follow the same procedure that I'm going to use for the entire modding of curving wires that have solder points close to the socket and leaving some loose wire for points that are further away. Instead of trying to use the strobe line, I went back to using the direct 3.3 volt LED power source, which the Monotribe generates right here from this little regulator. So I'm just tapping off a via to the 3.3 LED power source. So I changed that yellow wire that used to go to the strobe line here, and I've made it a longer wire that curves around there. And you can see when I put this on, it clears that wire which comes across over through here, and that works much better. It's a solid LED. It just means that I'm using a little more current now when I'm not using the strobe line, but it's the LEDs look much better, and there's no leakage of strobe frequencies. On the back side of this, one of those wires, this right here is a ground plane via that I cleared out, and I've run the ground wire through. And with this one, like I mentioned before, I took the file and I just put it on the top of the pad and squiggle it around a little and remove some of the solder mask. So I made a kind of a little pad there that the solder would adhere to better. So that's the ground plane wire. The 5 volt wire connects up here. So that is the 2 connectors for the top board. Now I have the 4 other ones to do here, and I'm going to do those left to right, the opposite way from the way the camera is filming right now. But so I'm going to start on this one and move my way across here. With the first 6-pin connector, there's going to be 2 wires that I'm going to be tacking, one to this IC. That's the output of the op amp there for the envelope generator, and then I think it's the base of this transistor here for the input for the VCA. This pin right here I'm going to tack to those 2, and then there's going to be 2 vias up here I'm going to use, which I've cleared out, which are here and over here, and those are the rhythm mix and the rhythm mix out. And then I'm going to be using these pads of Korg from Korg, that the 8 drum outputs. What I always do when I'm using one of these pre-existing pads from Korg, or one of the pins on the chip or something, is I always take the soldering iron and I put a little bit of fresh solder on each of those things before I start, because this is old solder that's been sitting around a long time, and Just get adding a little bit of new solder to it will add some flux to the mix and make the soldering go much quicker. When you're doing these connectors down here, you can leave this board on and you can actually plug in. For example, I'm going to start with this one. You can plug them in before you start, hold the whole thing in place and start working with the wires like here. And often, if I'm having a hard time keeping the wires where I want them to, I'll use some tape just to tape the wire in place while I apply the solder. You can do that for all of these. So there's one tap point that's underneath this board, and that's the first wire on the third connector. So when I'm doing that one, I will have to remove the board temporarily to get that one wire attached. But all the rest of the tap points are in above it and easy to access. So the first of the 6-pin connectors is done. You'll see that there's still this piece of Kapton tape on here that was holding this one wire that's tacked on there in place. I can pull that up. So this one had 2 wires that are tacked there and there, and it had 2 wires that went through vias, and it had 2 that went to these big Korg pads. And the next connector's very easy. It's all 6 wires, and the next 6 wires in these 8 Korg pads. So this one is very simple. With these big pads, I don't bother even taping anything or holding it. Just heat up the solder and stick the wire in while it's heated up and hold still so I don't get a cold solder joint. So that's a very easy one. I'm going to complete that one next, and then I'll show you a little more on the third one to do. So I've got the last 6-pin connector attached. 2 of the wires went through vias here. 1 wire through a via up here. 1 wire went to a pad on the toggle switch. And these 2 are tacked. I don't know how well this can be seen in the video, but these last 2 points that have to be tacked, basically what I've done is across these little surface mount resistors, in this case there's 3 resistors that are all connected on one end, and that's where we want to tap. So I can just lay the wire across there and just on each of the resistors put a little, touch it, put a little blob of solder across the resistor and the wire. So that one is laying across there. And the same thing down here, except here it's 2 resistors that are connected on one side, and that's our tap point. So we can just trim that wire a little shorter and lay it across that top side of these 2 resistors and just put some solder on it. You can see how I've curved. This tap point is underneath where the board goes, which will be here once it's reattached. And that wire comes up and curves up here. This is the third connector here. So I've got 3, and the last one will be the power. That's this one. It's 3 wires, and that one's going to be the 5-volt ground and V-bias. So the final 3-pin connector is attached. We got a 5-volt line going through a via, the V-bias going through a via, and the ground line attached there. So this is what the bottom of the main board looks like once all the mods are done. And you can see on the top side of the board, these 2 connectors are done, and yet I don't have the output board attached yet. But even though I've removed those 6 resistors I mentioned before, I can plug this in and run it as is. You can see with the dip switch here, there's 6 places for the 6 resistors removed. 4 of those are from the drum outputs, and you can see right now I don't have the drum board normally sits on this side. It's not connected. So if I wanted to run this Monotribe right now and be able to hear the drums, I would have to slide those 4 switches there up. And the last 2 are the VCA and the VCO resistors. And again, the replacements for those are located on the output board at the top. So if that board is not installed, which it isn't right now, and I want to be able to use those here, the output of the VCO, I'd have to flip those two switches up. So now all 6 are up. That means I could take this, I can hear it. So that's stock Monotribe running right now. So once you've got all the modifications on the main board done, you can actually hook the entire kit together without even drilling the case first. You can see I've got the 3 sideboards, the front board and the 2 sideboards attached here. Then you can hear if I run it, you can hear it's going. So this is a way to actually test it before you go on to drilling the case. One thing worth pointing out while you're working with the kit is to extend the longevity of these cables, it's better to try to never pull them out of their sockets by the wires themselves. I mean, I'm using a professional crimp connector to make these cables, so they'll last a long time, but still better not to do that, especially some of the wires, the very small wires are 30 gauge, and they're apt to come loose if you try pulling in and out with these wires. So the best thing to do is, there's 2 methods. One is there's little slots on either side here that contain sort of little plastic tabs that lock in place. I just take a small screwdriver and I push those slightly. Doesn't have to be much, just a little bit of pressure there to make a gap right below where I can get the screwdriver in just a little bit and then pry it out like that. That's a very safe method. Here again on the top board with this connect, I'm just pushing a little bit in these locking parts, enough until I can get the screwdriver just wedged in there slightly and slowly prise it out that way. Lastly, on the interconnect board where I actually had room to put the connectors so that they stick out beyond the edge of the board a bit, I can't do that on the top board. On these, since you can access these tabs on the side, you can pry the connectors out using a little screwdriver on the side and just rock them back and forth. This is an even less destructive method of removing these connectors. So you can get to that point and pop it out, slide it below the connector. So you see I can just jimmy them out that way. That is the safest method for removing these. You can't always access those though.